Hey guys, here is the second video for this lectures, and we're gonna continue to cover some example. So let's start with the first example here, as we did in the previous video, series connections. And now let's go with the parallel connection in that case. What we can find when we have couple of the resistors, they are connected in parallel, what the relation of the equivalent resistors with those combination of resistors. So the formula that we are talking about when we have parallel connections, the parallel connections, again, they are sharing for two terminals. That's how I identify the resistors, they are connected in parallel. Then I have the formula that to find the equivalent resistors using 1 over R1. So I have in that case R plus 1 over the R2, which in this case I have 200 ohms, plus 1 over the third R, 1 over R. That's how we find out the value of the resistance. So just to make it easy for you to imagine, let's assume R equal 500, for example, 500 ohms. So now I have 500 here and 500 here. So I end up with the 1 of the R equivalent. It will be 1 over 500 ohms plus 1 over 200 ohm plus 1 over 500 ohm. So now the way how you did it, you can plug it to your calculations and find this fractions, then reverse these fractions to find out your equivalent resistor in that case. So according for my calculation, if I did it right, so this is one will be 110 ohms. How do you verify your answers? Again, in the series, the equivalent resistance should be larger than. In the equivalent should be less than. So I have 200 and 500. So I end up with the resistance 110. So that's what I expected to see. So my answer is the total resistance is less than 200. Why is 200? Because the second resistance is 500, larger than. So the lowest value of my combination is 200. So this the answers will be this one. Let's move for second questions here. And we're gonna dealing with the Kirchhoff laws. And in that situations here, we're gonna use the Kirchhoff law for the potential difference. And asking for the potential difference, here is the Kirchhoff law stated that all the elements in the circuit equal 0. The way how to apply it, and you make sure you apply with this one, your path of your current should be I start with this point here, I go this way here, and go back here, and down here, then you go here. I close my mesh or my loop. So I have to follow applied Kirchhoff law in the closest loop. So let's, for simplicity, let's assume they are series connections. Let's assume the current here equal 1.5 amps, just for the simplicity. 1.5 amps. Again, to find the summation of in the loop, so that's the mean of the loop, the closest path. And we need to add the summation of my voltage in each element, in the voltage source, in the 3 resistors. Or we can, it's the same thing like this one. So we can, the voltage through the resistors, they are minus the voltage across the battery. In other words, the voltage, I have 9 volt. This 9 volt will be distributed in the 3 resistors. How distributed? Based in the ohm resistance. So for example, here I have delta R1. Let's call this one's R1. Delta R1 will be the current I times R1 times 1 ohm. I have 1.5, so this is 1.5 volt. Delta R2 in the 2 ohms, the same thing, I times 2 ohms. and 1.5 will be 3. Now, without calculating the fourth one, 1.5 plus 3, 4.5, I have 9. So my voltage, the remaining voltage will be 4.9. Let's confirm that. Delta R3 will be I times 3 ohms. I end up with the 4.5 amps. Volt, sorry. So here's to confirm this one here. Delta VRs equal minus the batteries, which means I have plus 9 minus delta R1 will be 1.5 volt minus 3 volt minus 4.5 volt. If you add this one, will be equal 0. So this is the formula for the Kirchhoff law. Make sure it is valid. Another one you wanted to see, imagine again, just to, as I mentioned before, we have in parallel and series connections. I mean, the voltage, it should be divided on the resistors. Since we have one voltage current. Graphically, that's the voltage of the batteries. It should be distributed between delta V1 and delta V2, which that's basically the voltage or the Kirchhoff law. So delta V for the battery equals summation of the two other batteries. So you can say this one is the delta V battery minus delta V1 minus delta V2 equals 0. Or you can take delta V, sorry for my bad writing, here's delta V of battery equal delta V1 plus delta V2. So all this one just rewrite the Kirchhoff law in different way. Okay. So that's the interpretation for the graphical part. See with this example how we're gonna solve the circuit based in the Kirchhoff law, which basically we need to identify the sign of the voltage or the current through the element. Here I listed something here to just to make it sure. The first one, you assume the direction of the current. So you select the direction of the current. That's the circuit and travel around the loop. So traveling around the loop means starting from the point and you have to stop when you get back to the same point. Okay, and just adding every potential difference in any element in your way on your traveling. And now you have delta V downstream minus upstream. So here is the something maybe very useful, guys. When we have battery moving from the negative to the positive, because it is power supply, in this case we call it, delta battery should be positive. If you are assuming your path and you are moving from the positive terminal to the negative terminal, the only change is here is that you add a negative here. Don't forget that. For in both first two cases, we have a power generator or the source of the power. Now, regarding for the resistors, all the time, this one we call it sink, or we call it this one what we waste the time, or sorry, waste the energy, okay, or observe the energy from the source. It's not gonna generate any power or any energy. It just observe the energy, okay. So in that case, moving from the positive terminal to the negative terminal, you have to add it minus in the front of the I times R as the Ohm's law. Okay. Now let's see how we can solve this example here. Let's apply this one numerically right now. How we can write that case. So the first one, I draw the circuit. The second one, I pick up a directions. My directions will be up in this case. This is my directions. Okay, so now this one is going to be negative, positive. Here is the positive, negative, and here is the positive, negative. Okay, now the third one, I travel around. I will select this point here at starting point. I'm going to travel around this path. Okay, so the first one I have positive to the negative, the current go that way. So here should be positive 9 volt. Here for the resistors from the positive to the negative. So I have one current. Here is the I. Plus, here not the plus, it is minus. If you just confirm that, guys. Here we go. Okay. So here gonna be minus I times 12 ohm. Then minus I times 15 ohms. Now I get back to the same loop, or I closed my loop. This is the ohm or the Kirchhoff law for the voltage equal 0. So what we have from here, we have here is the 9 volt minus I have here is the 12 plus 15, 27. So here is the I times 27 ohm. This one is equal 0. Then I can find my I. In that case will be 9 volt divided by 27 ohms. You end up with the 1/3 volt divided by ohms, which will basically 1.33 amps. So that's I apply the entire loop and I apply the Kirchhoff law to find the current through my circuit. Here is the most general one, start from the scratch. They give you the practical circuit. That's what you have. We have 2 batteries and we have 2 resistors. So let's follow step by step. So draw the circuit. I'm gonna start drawing the circuit. I start from this point until I get back. So I start from here, negative to the positive. So I have here is the positive to the negative. Where is the volt? This one is the 1.5 volt. I go up. I found here is the 25 ohms. So I draw my resistors as 25 ohm. Then, guys, I am follow this direction right now. Here, start with the negative. So here is the negative, and here is the positive. So this one is the 9. So I'm gonna add another one. So here is the 9 volt. Okay. So right now here, and the positive terminal, I am here. Now I go and find another resistors here. So I draw another resistors, which 80 ohms. And from there, the resistors, I'm gonna move to go back to the point that I start my loop in it. So I go back to the place where I am start with. So this is the first one. What asks me for the second? Choose the direction of the current. I will choose this path. You can choose something different, but I choose this path. And here's the current of the I. Write the Kirchhoff law. I'm gonna start as we did before. Here is the plus 1.5 volt minus I times 25. 25, sorry. Here is 25 ohms plus 9 volt and minus I times 80 ohms. That's 1 equals 0. I start from the point and I get back to the same point which start with. Okay. So now just I'm gonna add those terminals together. So what do we have? Here is we have 1.5 and we have this one. Here is the 10.5. 10.5 volt. Here's the minus I. I add 2. Here is the I. Here is the 25 and 80. 105 ohms. This one will be 0. This is the equation that I am looking for. Solve the equation to find the current. So from this equations here, I can find 105 I. Okay, this one is equal 10.5 volt. And here is the current. It will be 10.5 volt divided by 105 amps. 105, not 08 of amps. And this one will be in up is the 10, 1 over 10, 1 over 10 volt divided by amps, which will be 0.1 amps. So that's the solve for this equation to find the current. Okay, I am done for this lecture today, guys. Thank you so much for listening, and I hope you found this video useful. Thank you. Have a great day.